So in this video, we have once again a system of linear equations, and we have to find a solution of x, y, and z. And these linear equations are inconsistent. That means they have no solution. Let's see what that means. So we start by making an augmented matrix. We can also convert them into three different matrices, but I'm skipping that step. So I have 1, 1, 1. So x is 1, y is 1, z is 1, and 1.
Isn't that 3?
Oh, z is 3. Thank you very much. Good catch. Please continue to find my mistakes so that I don't make any mistakes.
1, 2, 4.
1, 2, 4,
3.
and 3.
1, 3, 5, 2.
1, 3, 5, 2. Okay. So now I have a valid augmented matrix, and my aim is to make it into row echelon form or to reduce row echelon form, but I will just make it into row echelon form. It's fine. So I want to have 0 here and 0 here.
Is it ever like a must that you have to make it in the reduced rotation form or like here?
No, it's not a must.
Always a choice.
It's, if you make it to reduced row echelon form, you don't have to do backward substitution. You have just here 1 and here you have answer. You know what I mean? In reduced row echelon form, you have answer directly. You don't have to do the backward
Does that
substitution.
mean I don't need to learn reduced rational form?
No,
I can just learn 1.
You have to learn it, but you might not have to use it often.
Okay.
So let's convert it to row echelon form. We want here 0 and 0, and this looks very simple. How can we make it 0 here?
Simple. Row 2.
Row 2.
And then it is equals to row 2 minus 0.
Minus 0?
Minus 0. Oh, it's just minus row 1.
Minus 1. You cannot multiply with 0. We should not multiply with 0, doesn't make any sense. So this is our one operation. Then we have another operation, row 3 is equals to
row 3 minus row 1. Or
row
we can also
3
do, can we also do row 3 minus row 2?
No, not in the same step. If we're changing one row and using it in the next row, then we should do in two different steps. We can't combine two steps where same row is involved. So now let's do those operations on this augmented matrix. So I will have what here. I'm quickly going to write the first row because it is not changing, and the second row I have to just subtract first row from the second row. So it's going to be 1 minus 1, 0. 2 minus 1 is going to be 1. 4 minus 3 is going to be 1. 3 minus 1 is going to be 2. Similarly, here is going to be 0, and 3 minus 1 is going to be 2, and 5 minus 3 is going to be 2, and 2 minus 1 is going to be 1. So now I have my first pivot ready, and if to make this one pivot, I must make this one 0, because we can't have a pivot below a pivot, because all the pivots must be, the pivot from the third row must be on the right hand side of the pivot of the second row. So we have to make this one equals to 0. So for that, what operation I will do?
Row 3
Row 3 is equals to?
is equals to row 3
Row 3
minus 2
to
row 2.
row 2. I can't use row 1 because row 1 has this one. I want to use this one. So it's going to be 1, 1, 3, 1. So I'm just writing first two rows because they are not changing. 1, 1, 2. The third row we're going to have here 0, 0, 0,
0.
and then here we will have minus 2, minus 4.
Yeah.
Minus 4 plus 1 is going to be
5.
no, minus 4 plus 1 is going to be minus 3. So it's minus 4 plus 1 is minus 3. So now we have our row echelon form, but the problem is this, that we have here a pivot corresponds to x, we have a pivot corresponds to y, and we have no pivot corresponds to z.
Free variable.
So it will be that will be a free variable when we have 0 here, because in that case we are saying nothing about that. But in this case, we are saying that 0z is equals to minus 3. Or in other words, it's saying that 0 is equals to minus 3. So the third row is saying that 0 is equals to minus 3. It does not make any sense. So if you don't get it, it's fine, because it doesn't make any sense. 0 cannot be equals to minus 3. If we have a 0 here, that means that the third row is not saying anything about z, so z is a free variable. But we don't have a 0 here, we have here minus 3. That means the third row is saying that 0 z is equals to 3, or it is saying that 0 is equals to minus 3. 0 is not equals to minus 3. So it is an indication that this system linear equation is not consistent. So that means, because we have a condition that will never occur when our system linear equation is consistent. So this implies that our linear equations are not consistent. Hence, we have inconsistent system of linear equations. Hence, no solution exists. So in case when we have a row where all the variables are equals to 0, but on the right hand side we don't have 0, then this is the indication that our system is not consistent and no solution is possible. And that's the case we have here. So I have shown 3 different examples. In the first example, we have a unique solution. In the second example, we have infinite possible solutions, and from those infinite solutions, I have shown one solution by taking free variable equals to 1. We could have taken free variable equals to any other value to find any other solution. In the last example, we have shown a system linear equation which is inconsistent, hence no solution is possible. I hope that now you will be able to solve any kind of linear equations. If not, then I'm going to write some homework examples for you to solve so that you can practice. So stay tuned, see you next time.